by trying to come up with the predictions, meaning things that we have not observed yet, and what would the theory tell us if we actually go and do the experiments. And once we do that, and the experiment agrees with the theory, then we have more confidence in the theory. And the theory remains in our mind correct as long as the experiments agree with its prediction. Once the prediction starts to deviate from the experiments, then we know that the theory is no longer valid in that particular area of science. And we're going to see examples of how these things happened, throughout the history of science. So I'm going to be covering a little bit of history, a little bit of the evolution of astronomy and cosmology. At the same time, let's remember that the Bible is not intended to be a scientific. Is this better? Okay. Is not intended to be a scientific treaty in the sense that we understand science. The Bible is not set up to prove to us God's existence. As Pastor Michael read, it gives us that as a given. God, in the beginning, God created the heavens and the earth. There is no attempt to prove anything because God does not need to prove himself. In fact, the creation as a whole is his proof. So the Bible is not meant to give us a scientific theory of how things work. The intent of the Bible is mainly to, as Peter says, to give his divine power has given us everything we need for a godly life through our knowledge of him who called us by his own glory and goodness. That's the intent of the Bible, is to teach us how to live a godly life and how to have a relationship with him. So therefore, we should not mix the Bible with science and be confused in thinking that the Bible is telling us a scientific theory that we should pursue. On the other hand, the Bible tells us the purpose of the things we see. So it is not a function, it's not a question of how things work, but why they are there. What's the purpose of our existence? Science cannot attempt to answer these kind of questions, but the Bible tells us that kind of answer. So it is the how versus the why. The science is telling us how things work, but the Bible is telling us why things work. So for example, when it says in the beginning God created the heavens and the earth, it's telling us a reality which is a lot more profound than whatever science can tell us. And also when it talks about in the beginning was the Word and the Word was with God and so on, again, this is a reality which is everlasting, for everlasting. So it's not a science per se, but it is a reality that is true now and forever and ever. And we will not understand the full depths of all these words until we are again united with God. By the same token, even though science is not the Bible is not a scientific book, it does use the creation as a way of pointing to God. So for example, the heavens declares the glory of God, the skies proclaim the work of his hands. Another thing that we read in Romans 1:20, for since the creation of the world, God's invisible qualities, his eternal power and divine nature. Michael, don't play with it, please. His eternal power and divine nature have been clearly seen, being understood from what has been made, so that men are without excuse. Sometimes we might ask the question, how is the creation show us his eternal power and divine nature? And in what sense does creation show us his eternal nature and divine, or his eternal power and divine nature? I will come back to that at the end of my talk. Again, examples of where God is using the creation to show his power. When he talks to Job, remember the story of Job. Job is complaining throughout the entire book of Job, and finally God appears toward the end of the book in chapter 38, and he reminds Job of who he is. And how does he remind Job? His biggest claim is the creation itself. Okay, he says, look at the creation. Where were you when I laid the foundations of the earth? Who determined its dimensions? What supports the foundation and who laid the cornerstone? Do you realize the extent of the earth? Where does light come from? Where is the path to the source of light? Can you direct the movement of the stars? And so on. He is pointing to his own creation to remind Job of his power. So even though the Bible cannot be taken as a science book in the way we understand science, God uses the creation as the cornerstone in which he shows his power and might. So we need to keep these two things in mind. So let me start with a little bit of history. The earth was not known to be round until around the time of Aristotle. Aristotle said the earth must be round for a few reasons. He looked at the eclipse of the earth or of the moon. When the sun is shining through the earth, you can see that the eclipse is round, or the shadow is round. This to him was the first proof that the earth is actually round. Another thing he noticed is that when you look at the stars from a different position on earth, when you go higher, for example, you will see them lower in the horizon than if you are standing here, which means that the earth has curved. Of course, the third thing that was obvious to them is that a ship will only appear at some point in the horizon when it's coming through the ocean. So Aristotle proposed that the earth is round. On the other hand, Isaiah, who, by the way, Aristotle existed about 300 years before Christ. Isaiah was around 600-700 years. He made this statement: he sits enthroned above the circle of the earth. There is a hint in the Bible about the spherical shape of the earth. Job, who is believed to exist about 2,000 years before Christ, he says he stretches out the north over empty space and hangs the earth on nothing. Hangs the earth on nothing. So there is hints in the Bible about the earth's shape and the fact that it is hanging up in space by itself. So let me go back 2,000 years before Christ. The Babylonians were the first to map the sky. They had a very strong interest in astronomy. And if you look at the sky, what you see is a bunch of stars, but they also notice that there are some stars that are brighter than others. And they notice another thing, is that these stars, they actually change their position around the year, whereas the other stars are fixed. Aside from the fact that they all rotate, because the Earth itself is rotating, although they thought that the sphere of stars is rotating, all of these stars are fixed relative to each other, whereas those stars, or planets rather, they are moving with respect to everything else, which is why they quickly figured out that these must be planets. In the same way that a moon is a planet, they figured out that these must be planets, and in the same way that the moon appears to be rotating around the Earth, they also assumed that these are planets going around the Earth. So they call them Mercury, Venus, Mars, Saturn, Jupiter. And that's how the first model of the universe came out. It was set forth by Ptolemy, who lived about 100 years after Christ, who said that the Earth is at the center of the universe, and then comes the moon in the first circle, goes around it, and then comes the next planet, Mars, here, Mercury, and then Venus, and then the Sun, and then Mars, and then Jupiter, and then Saturn. And then comes the stars. So you see each of those circles represent the rotation of the planet or the stars. And the church quickly adopted that as a scientific theory that is consistent with the Bible, because it simply shows that the Earth is the center of the universe, and that the stars that they see are rotating around the outmost circle, and that certainly left space for all the angels and for God and so on in the outer space here. And you can see this is a picture that represented basically the faith of the Catholic Church until the 16th century. The Ptolemaic model simply showed the following picture. Imagine the Earth slightly off-center here, and all the stars or all the planets are circling around it. And to account for the fact that the Earth is rotating, although they didn't know that the Earth is rotating around the sun, they said, okay, this planet is actually rotating, because this rotation explains some of the observation they see in terms of the stars actually moving and sometimes going backwards. So it's loading a movie, so it will take a minute. The movie will actually show you what the Ptolemaic model looks like. Can we click on the view graph? Let me say that this theory stayed valid in their mind for nearly 1,500 years, simply because it explained the observations very well. And even though it doesn't explain everything, but it was good enough. Maybe we can skip it. Is it? Sorry? It's not going to work. Okay, we'll skip it. So anyway, the picture shows you, the movie actually shows you the rotation of each planet around the Earth, and it's doing this kind of thing. So you can think of the sun doing this kind of thing, and everything else is rotating like that. And it explains the observations fairly well. Until 1543, an astronomer by name Copernicus, from his observations, he came to the conclusion that this cannot be true, that actually the sun is at the center and the Earth is rotating around it. But he didn't have the courage to speak out, because he simply knew that the church will go against him. Until he finally published a book at the year in which he died. So before he died, he published a book stating that theory. Just to show you the reaction of some of the prominent Christians at the time, Martin Luther called him a fool who went against the Holy Writ, meaning against the scripture. Next came Galileo, who is a professor in astronomy, who believed in Copernicus' theory, and he taught it, and he claimed it, until the church in 1916 forbade him from teaching about the center, the heliospheric theory, which is that the sun is at the center of the universe. In 1623, a new pope came to power who was a friend of Galileo. So he gave him permission to actually write about his theory in a book he called Dialogue Concerning Two Chief World Systems. The two systems he described is the geocentric model, which is the Earth is the center of the universe, and the heliospheric model, which is the sun is the center of the universe. And the condition was that he would not state his own opinion, that he would be neutral. Okay? But it was clear after he wrote the book that he was actually very much biased toward the heliocentric theory. So he was called by the church again, and he has gone into a court and judgment and all that stuff, and he had to declare that he does not believe in the theory, heliocentric theory, and then he was also put under house arrest, basically, until he died. Now, we might ask the question, why is the church so much against the idea of the Earth going around the sun? And they thought that there are verses that clearly proves otherwise. So, for example, the Lord reigns. He is clothed with majesty. The Lord is clothed with strength, wherewith he has girded himself. The world also is established that it cannot be moved. The idea that the earth is moving seems to fly in the face of this verse in the Bible. Another place says, the Lord set the earth on its foundation. It can never be moved. Psalm 104. Another place in Ecclesiastes, the sun rises and sets and returns to its place. But Galileo pointed out that these are observations from a point of view of somebody who is on earth, because that's how things appear for somebody who is on earth. And there is no reason, no contradiction by saying, okay, actually the earth is moving. There is no contradiction necessarily to these verses. And the reason I bring up this example, because today we seem to have a huge gap between people who believe in the creation as a 6-day, literal 6-day creation, and people who believe in creation as a very long time, estimated to be billions of years. And people who insist that it is a 6-day creation have no basis for their belief in terms of evidence, in terms of observations. The only basis they have is what it says in the first chapter of the Bible, that on the first day he did this, on the second day he did that, and so on. We'll come back to that later. But I just wanted to keep this kind of history in mind, because it tells us that our understanding of the Bible can be quite wrong. And we have to think a little bit out of the box to understand the bigger picture. Finally, in 1687, Isaac Newton, a British mathematician and astronomer, came and he laid out a theory which basically became the basis for all the physics to come in the next 300 years, which is called classical mechanics. And that theory explains the movement of the stars, or rather the planets, in exact detail. It shows that it agrees perfectly with experiment. And there was, beyond that point, there was absolutely no question that the sun is the center of around which we actually rotate. And it also became clear that the universe itself is not a set of stars rotating around the sun, rather that the sun is one of many stars. So let me tell you quickly the view at this point. So by the time of Newton, all they have known are these set of stars up to Saturn. It was not until the 19th century and 20th century that these stars were discovered because of improved telescopes and so on. And the picture became clear that all the planets are rotating in the same orbital plane. This is the orbital plane around the sun. And notice another thing is that they all rotate in the same direction as the sun. Now forget Pluto, because Pluto was considered not a planet anymore around the sun or part of the solar system. It was captured as it was coming from outside. But actually those stars are rotating in exactly the same plane, and they all rotate in the same direction as the sun, and they all also rotate around themselves like this. And physicists think about the cause of these things, and they model these things, in computer models and so on, and they understand that this formation actually happened in one go. In other words, the sun and the star and the planets all formed together. And I will show you some pictures later to sort of illustrate the picture, the idea to you better. This is a picture of the sky at night, which you can see pretty much with the naked eye. What you see here is what's called the Milky Way galaxy. It's called Milky Way because what you see is sort of like milk scattered over the sky. And it's really essentially it's the interstellar dust, which hides the core of the galaxy, and we will see some pictures later. It hides the core of the galaxy from our eyes. But the way we are looking is we are sitting within the plane, so the entire galaxy is sitting on a plane, all rotating in the same direction, like this. and the sun is rotating with it. But we are inside that plane, so we cannot see the galaxy from above. We can only see it from within the plane, which is why it looks, so this is the plane of the galaxy, and this is the center of it. We are looking through it. It was believed that every star we see is actually within our galaxy. Particularly, there is an object here, which if you look at it in the telescope, it looks cloudy. It looks like a little cloud. It's called Andromeda, and it was actually recorded the first time by an Iranian astronomer in the 1900s, in the 900s, who thought that it was simply a cloud. And astronomers in the beginning of the 20th century had a huge debate whether this thing is actually just an object of clouds. They call it nebula. Nebula means a collection of clouds, or a galaxy by itself. And they could not figure out how to resolve that issue until finally, in 1923, they built the biggest telescope at the time. The telescope you're seeing here is on the top of Mount Wilson, which is right in Pasadena. If you drive up an hour on Highway 2, you will get there. Its length is about 100 inches, and this is the first time they are able to probe so far into the galaxy. And this is the picture that the astronomer Hubble, his name is Hubble, obtained for that little cloud that I was telling you about, Andromeda. This is what the picture looks like. It became clear immediately from the picture that this is a galaxy by itself. So we're looking at billions of stars sitting right here. Hubble is the astronomer who actually came up with that picture, but he did a lot more measurements, which I will talk about later. In his honor, they actually built a satellite in 1990, and they launched it, and they took pictures of the sky from above the atmosphere. And here is the same picture of that same point of clouds. What we're looking at is a galaxy which looks exactly like our galaxy. The advantage here is that we can see it actually from above. Remember, I said when we are looking at the Milky Way galaxy, we are sitting inside of one of the arms. We cannot see the whole thing from above. But here's the advantage of seeing the whole thing from above. The Andromeda, the dimension of this is measured in light years. And let me tell you what a light year is. We measure distance by the time it takes for the light to go from one point to another. So for example, light travels at a speed of 300,000 miles per hour. To go around the Earth, it takes about 0.1 second, okay? So it goes around the Earth 10 times in 1 second. We measure light in light years, which means the distance that a year traveled in 1 year. Just to give you a grasp of how big that distance is. There is roughly 3 million seconds in 1 year, okay? So imagine unwrapping the Earth's diameter 10 times, and then 3 million times. In other words, unwrapping the Earth's diameter 30 million times. That's how much the light will travel in 1 year. And that's what we're looking at here. We're looking at a diameter which is 100 light years from beginning to end. 100 light years. And the number of stars here are estimated to be 100 billion stars inside of this galaxy. A billion is 1,000 million. So there's 100 billion stars in this little dot, which they thought is just a bunch of cloud. Here's another picture of our own galaxy taken from Hubble. And here's an enlargement of some of the stars in the center. And look at the density of these stars. And this reminds me of a couple of verses that God said to Abraham, I will surely bless you and make you descendants, make your descendants as numerous as the stars in the sky and as the sand on the seashore. Interesting that in our days, we can actually estimate the number of stars, and we can estimate the number of sands in the seashore. The number of sands in the seashore are estimated to be 1 with 19 zero next to it, okay? 1 with 19 zero next to it. The number of stars are actually about 1,000 times more than that, okay? This is how much God is going to bless us. Thank you. So here's actually a picture which is envisioned. This is a picture of the Milky Way galaxy. Now remember, we cannot take a picture of the Milky Way from above because we are living inside of it. And we cannot send a satellite that high because it's way too far. But we can envision how it looks like simply by knowing the location of all the stars and putting them on a map. And that's what it looks like. It has such a dense center at the core, and it has these beautiful arms, very symmetric arms. And those are called spiral galaxies, and we see them over and over. So remember when I said that the sun is rotating in the same direction, and also it's the same direction that the entire galaxy is rotating, basically. All right? So the whole thing formed as a one go. The sun is, by the way, sitting right here, about 2/3 the distance from the center. And this is a very special location because if we were much closer, life would have been impossible. And if it were farther, life would not have been possible either. This is our galaxy again in reference to other galaxies around us. So remember, we talked about the Andromeda galaxy, and this is our galaxy. And there's a number of galaxies around us here, and they are clustered together. We call them the local group. For some reason, the universe clusters galaxies like that. So we see the local group, and then in the local group, we also see like a super cluster, and then that super cluster is far away from another super cluster. So just to give you a sense of the scale, here's our solar system. It's 8 light hours. The light will take 8 hours to travel from one end to the next. So here's Sun, Mercury, Venus, Earth, and so on. It's 8 light hours. Here's the stars that are in our neighborhoods. And we're talking about 40 light years just across this, right? And you can see some of the stars these are some of the stars that are closest to us. This is the solar system. This is our galaxy, which is sitting in an area here, 500,000 light years. This is our galaxy in the local group, and this is Andromeda galaxy. The distance here is 4 million light years. And then we look at a supercluster, or super cluster of stars. Here's our local cluster, the previous image, in reference to other stars. And this cluster is 150 million light years across. Now, this might appear to be big, but let me tell you, this is just 1/100th of the size of the universe. The universe extends another 100 times on either side, which means that the volume is 1,000,000 times bigger than what you see in this image, because it's 100 on each side, basically, so that's 1,000,000 times bigger. Now, you might wonder, how do we know of how many stars we have and so on? I mean, it just seems like nobody's able to count all these things. But the way we know is the following. Here's the moon. If we take a little area here, which is about 1/10 the radius of the moon. This is just a very tiny area. So Hubble kept looking at this and basically taking the exposure over an extended period, a 4-month exposure, to see what it can record in this little area. Here's the image that it comes out. We don't see the full resolution. There's a lot more dots that we don't see. But every little dot here is a galaxy by itself. So for example, that little dot that I was pointing to is a galaxy by itself. And every other dot here is a galaxy. And just to understand how this is working, let's imagine Hubble sitting at the beginning of this cone. What it's doing is that it's taking the picture from all the planes in this cone. So it's seeing stars that are 5 billion years away, and it's also seeing stars that are 9 billion years away, and it goes all the way to the end, basically. The farthest we can see is about 13 billion years, which also tells us not only about the distance. Keep in mind that light travels at a finite speed. Light doesn't travel at an infinite speed, which means the light that came out of this plane here took 13 billion years to arrive to us, which means that we are looking at stars that were formed, that came to existence 13 billion years ago. In other words, as we probe deeper into the space, we are seeing back in the past. We are able to see back in the past. I hope this idea comes across. But basically, it's like somebody, let's say if I shout something, by the time my voice comes to you, if it takes a long time, then you are hearing something that I said sometime in the past. So we are able to probe not only space, but we are able to probe time. Just to show you some pictures of other galaxies, this is considered one of the most photogenic galaxies taken by Hubble. Here's another galaxy called Sombrero, because it has the same shape as a sombrero. But it has a majestic light inside, which is a tremendous core of stars. But those are stars. Here are two galaxies which are forming together in a shape that looks like a rose. It's like a flower. So here's the first galaxy, and here's the second galaxy. And the two are actually interacting because of gravitational attraction. Here is two galaxies that are colliding together. So at some point, again, two spiral galaxies, at some point they will merge into one galaxy. And here are two galaxies that actually merge together. It's called antenna galaxy because it looks like an antenna. And here's the first one, here's the second one, and they're actually merging. You can see that the stars and all the gases are coming together. Here we're looking at a region, it's called Eagle Nebula, which is a collection of gases. And the importance of those is that it's considered the incubator of stars. That's where stars are born. Because the way it works is these gases attract each other, and they come together, they concentrate, and finally, the gravity will pull that concentration together to a point where a star is formed. And that concentration brings all the gas together in a way that they start fusing with each other. So this process, fusion, which we see in the sun, is when two hydrogen atoms are fused into one helium atom. In the process, it gives a lot of light, a lot of heat. This is just enlargement of this particular area. And it's called the pillars of creation. Again, it's called pillars of creation because that's where we believe stars, in a similar environment where stars are created. Just to give you an idea, this little finger here is the size of our solar system. So this whole thing is like a light year long. As I said, when you have a nebula like that, a gas nebula, that's where the star is born. A star, here's it can be a small one or a big one. So here's a small star, sort of similar in size to our sun. When the hydrogen fluid runs out, essentially what happens is that it expands because it runs out of fuel, and it becomes what's called red giant. And at that point, it starts fusing not only hydrogen, but also helium to form more heavier elements. And finally, when it runs out of elements to burn, it runs what's called a white dwarf. Bigger stars come to similar paths, but finally they come to a point where they create a supernova. A supernova is a huge explosion that gives enough light as much as a whole galaxy. So you can see one supernova appearing in the sky. It appears as bright as a galaxy by itself. And that supernova essentially is spreading out all the gases again out in the universe, which becomes the gas for the next generation of stars to be born. Okay, I was telling you about how the sun and the solar system is formed. So basically, again, the hydrogen gas will get closer together, attracted by gravitation. And you can see around it here other matter that are forming. And those actually become the planets. So it is this one system that's rotating, where those concentrations come together, become the planet. And this, in the center, becomes the sun that shine to the planet, basically. This is our sun. In 4 billion years, it will run out of fuel. And when it does, it will grow into what's called a red giant. It will become this big. This is the end of the life of a sun. And after it has given away all its energy, it becomes what's called a white dwarf. A white dwarf, which means that there is nothing burning inside here anymore. It's only given heat, but in a very low form, and it looks white. And we actually see these in the sky. And as I mentioned earlier, it's in the sun. This is a table of all the elements that we see in the universe. Inside the sun, when it's initially burning, it's burning hydrogen and forming helium. At the end of the cycle, it finishes all the hydrogen it has, so it can only burn helium. And that's when helium starts merging together and forming heavier elements like oxygen and so on. And the heaviest they can form is iron. Iron is the heaviest they can form, until they go into this supernova, this super explosion, because the condition before that, they did not have enough energy to form the heavier elements. But until they explode, they actually form all the rest of these, everything you see here. So we know that all the elements are formed inside of a star and when the star explodes, which is why people say now that we are actually formed of dust, of stardust. Our material is formed out of stardust. So let me get to the topic of Big Bang, because Big Bang has been considered by many Christians as the creation moment. And I'm going to go quickly over this because I know that you might have questions and would like to bring them up. But is that what Genesis 1:1 is talking about? In the beginning, God created the heavens and the earth. Big Bang might appear as a simple idea that somebody just dreamed of overnight. And let me tell you what the popular conception of Big Bang is. The popular conception is that space is a theater in which things happen. And here we go. Matter started like a big explosion in inside of that theater. Okay? And that God brought the universe from that explosion forward. But the Big Bang is actually much more subtle than that, because it's saying that space itself wasn't there. There was no space, no time. That the space started at a particular time, and a time started at a particular moment. And this all can be derived from the general theory of relativity, which is expressed in a very elegant formula, and it has so far-reaching implications. But what it's saying is that space itself is actually wrapped in a way that is influenced by matter, and matter is influenced by space. It's a way to explain the motion of bodies around in space. One of the observations that Hubble did, remember Hubble is that famous astronomer I told you about who looked at the Andromeda, is he looked at several galaxies at different distances. So here we look at a galaxy close to Earth and then a galaxy far away from Earth. And here we look at their velocity. We can actually measure the velocity of the galaxy and see how far is it moving from us. And what he noticed is that the farther the galaxy is, the faster it is from moving from us. This was a remarkable observation, which immediately led people to think of the idea that space itself is expanding. So here's to understand how. Here's the moment of creation, or the Big Bang. Here are the galaxies. Now think of that as being the universe, this flat surface. And it was small in size. But then it started growing, and those galaxies are getting apart and further apart. So each galaxy is getting further apart from each other, and the farthest the galaxy is, the fastest it will move. Another observation that proves to us the Big Bang theory is two scientists at Bell Lab noticed that there is a hissing or noise in the, Bell Lab is interested in radio and telephone and so on. So they were annoyed by a hissing or a noise that was coming at all time. They just could not get rid of that noise. So they set up an experiment in which they actually built this huge horn antenna, looks like a horn, and they looked at certain frequencies, they call it microwave frequencies, which are similar to the frequencies that come out of your cell phone. And they listened, they pointed out this antenna in different parts of the sky. And they noticed that it's, no matter where they point, they get the same noise. They went through so much possibilities. They even cleaned this thing on the inside because they noticed there's a pigeon that dropping inside. So they cleaned it and they pointed this thing in every direction at different times of the year, and they always heard the same noise until they realized that this noise must be coming from the cosmos as a whole. It's cosmic radiation. It's a cosmic wavelength that's coming uniformly from any direction in the cosmos. And the way to think of this is the following. If you have an oven which you heat up, let's say it's small at the beginning, it can become very hot, yes? And then if you expand that oven, what happens to the temperature? It will drop. It will drop. And that's exactly what's happening with our universe. Our universe is like a balloon that's expanding. At the time of beginning, it started with a tremendous temperature, but as this balloon grew, that temperature dropped. And that temperature is what they were actually detecting. That temperature is 3 degrees Celsius or Kelvin above absolute zero, if anybody has any idea what I'm talking about. But it's so tiny, but they can detect it with their senses. So this gives another proof of the Big Bang theory. There's a lot of details that I'm skipping here. Of course, the third proof, this is a detailed image of that temperature background that I'm telling you about. The reason scientists put up satellites to actually detect that very minute variations in this background temperature is because they said if that background temperature is exactly 3 degrees everywhere we look, that does not explain to us how galaxies formed. Because if that temperature is exactly uniform, then there should be no reason why one region would have higher density to form a galaxy than another reason. In other words, everything would be uniform. It would be like a soup. The fact that there are galaxies around us, they said there has to be variations in this background radiation. And sure enough, they put a satellite up and they look at the entire sky. This is a map of the entire sky showing this background radiation, and they notice slight variations. This is microkelvin. 1 millionth of a Kelvin changes in the background radiation. And we know now, based on the Big Bang theory, that this is what the universe looked like 380,000 years after the moment of start. It's essentially the incubation time of all the galaxies. So those hotter dots correspond to the points where galaxies actually formed. So you can think of this as the picture of the universe 380,000 years after it started. I'm going to finish soon, but let me just give you an idea how far scientists think they can go. I'm not going to cover everything here, but we are here. We are roughly 14 billion years after the moment of creation. Scientists think that we can understand things down to, it's hard for me to explain to you this number, but this is 1 divided by 1 over, with 35 zeros or 36 zeros next to it, of a second. This is how small of a fraction of a second they think they understand things, where all the forces were essentially the same. Roughly around 3 minutes after the Big Bang is when matters started to form. In other words, in the beginning, there was no atoms. Everything was light. Everything was a soup of all the particles that formed the universe, until matter started to form here, and then eventually forming these clumps together to form galaxies. Here's another picture illustrating the same thing. This is the moment of creation. The first 380,000 years is when the universe expanded and it created that image that I was showing you, the background microwave radiation, and then gradually the clumping of gases and the creation of galaxies. One most amazing fact that science arrived at is something that we read in Hebrew. It says, by faith we understand that the universe was created by the word of God, so that what we see was not made out of things that are visible. In other words, the author of Hebrew, he said, by faith we know that the universe is creating out of nothing. And that is exactly what science arrived at in the 20th century. This was not obvious to science by any means, but it was obvious to the author of Hebrew. Just quickly, to reconcile with some of the things we know today with Genesis 1. Genesis 1 splits the days of creation into 6. So it says on day 1, God created the heavens and the earth was watery, was all water basically, formless, void, dark. And then he said, let there be light. He created the light on the first day. He divided the light and the night, and he created the day-night cycle. On day 2, it says he separated the water from under the heaven and water above the heaven. In other words, he created an atmosphere. Okay? On day 3, it says he created the land, vegetation, plants, tree. On day 4, he created the sun and the moon and the stars. Day 5, water, creatures, birds. Day 6, land animals, man and woman, which is the culmination of creation and the ultimate purpose of his creation, to bring man and woman. Now, if we look at this carefully in the light of what we know from science, the orders might seem a little bit strange. For example, how could there be day and night, and the sun and the moon are not created yet? Okay? Which is why when Einstein first read this, he said, there is no way this is true. He basically discarded the whole thing. Even though, just to remind you, Einstein was a Jew, so this is the Bible he would read. On the other hand, if you remember what we read earlier about the earth is fixed, whose reference was it? It was a reference of somebody who is sitting on the earth. Yes? It would make sense also to talk about the creation from somebody who is actually sitting on the earth. Yes? From somebody who is sitting on the earth, if you think of the evolution of the earth, it did start as a body of water with complete darkness. And the reason it was complete darkness is simply because the sun could not penetrate through the thick cloud. Yeah? The thick cloud was so thick that it's so dark. When it says he created the light, it means that the light thinned a bit. I mean, the cloud thinned a bit, where it becomes, you can see the light through it. You don't see the sun, but you see the light through it. You understand? On a cloudy day, you don't see the sun, but you see the light. And you can certainly tell a day from a night. On day 2, he created the atmosphere, and we know that the atmosphere came to the earth later on. The earth did not start with an atmosphere. On day 3, he created the land, and we know that, again, the earth started with water, and the land appeared later. In fact, it appeared as one land, which then split into continents. On day 4, the sun, moon, and stars appeared because simply the cloud thinned enough to the point where we can see through them now. Yes, they became transparent. So again, from a viewer sitting on the earth, these sequences make a lot of sense. Water creatures, notice that it starts with water creatures, and we know that life started in the ocean, and then birds, and then land animals, and finally man and woman, and we know that man and woman are the most recent visitors of our earth. So this makes a lot of sense from an observer who is sitting on earth. But just to tell you quickly, there are so many different debates and interpretation about the Genesis accounts. And people can fight on and on forever. So for example, there is the young earth interpretation, which says one day is a literal one day, and we don't care what science tells us. Basically, we are throwing away everything that science is telling us. One day is one day because that's what the Bible says. But we forget that the Bible itself says that one day is like 1,000 years for the Lord, and 1,000 years is like one day. There is a gap interpretation which says that, okay, God created the earth a long time ago, but it became formless later. And then the rest of the Genesis account is telling us about the reordering the earth, basically. So this is just a way of sort of merging the modern theory of modern science with the Genesis account. And then the age interpretation is the one that I believe in, which is that one day is a whole period of time, which could extend to millions or billions of years. And then there is a framework interpretation, which, again, what I told you, which is that this is a description from somebody who is looking from the earth. There is the relativistic interpretation, which says that these are days with respect to reference of God himself. So it is a day that God is measuring and has nothing to do with our day. And then there's the appearance of age interpretation, which says that the universe is really new, but it was created to appear old. I'm just telling you these things because I have a simple statement to make, that no matter what you believe in fact, you can believe that the earth is flat, and that will not affect your spiritual life by not a tiny bit. It's not important what we believe the sequence of events in the creation is for our salvation, which is probably why God did not make it so clear. Let me finish with those. Einstein says, the most incomprehensible thing about the universe is that it is comprehensible. Ecclesiastes echoes the same thought. He says he has planted eternity in the human hearts. God has planted eternity in our hearts, which is why we can ask the question, why are we here? But he reminds us that But even so, people cannot see the whole scope of God's work from beginning to an end. I mean, we might comprehend a lot about the universe, but we cannot comprehend the whole thing. Now, let me come back to this verse, which I found so deep. For since the creation of the world, God's invisible qualities, his eternal power and divine nature, have been clearly seen, being understood from what has been made, so that men are without excuse. It is perhaps in our ability to probe so deep into the meaning of our creation and to find out so much that this is referring to, that God actually gave us that ability to know his eternal power and his divine nature. It is through these questionings, it is through contemplating on the essence and the how and the why of everything we see around us. Amen. We take time for questions? Yeah? Anybody want? Go ahead.
At the best breakfast, you mentioned something about the scientific theories about life. It had to have someone who had started in time. And you were talking about also space, that space was there, or space is made.
Right. So the idea is this. Scientists, when Einstein came up with his theory, his theory shows that the universe cannot be static. Okay, it must be either shrinking or expanding, but it cannot be static. He was so uncomfortable with this idea because the idea of a universe that is changing in size implies that it had a beginning. Okay. And if the universe had a beginning, then there must have been somebody who started it. He was so uncomfortable with this idea, so he put another term in his equation. He called it, it's like a fudge, term. He called it cosmological constant to make the universe able to be static. Okay? It was only later on that Hubble discovered that actually the universe is expanding. So if the universe is expanding, which means that if we play back in time, it's like playing back a movie backward, it was coming from a point. So that means time and space started at a particular point, which must be that somebody started it, because it wouldn't come by itself. So this is why a lot of scientists are drawn to believe in a moment of creation, because nothing starts on its own, right? Now, if something was there forever and ever, then it does not need to be started, because God himself was there forever and ever. Therefore, he does not need somebody to create him. So that's the huge difference between something that's there forever or something that has a beginning. Does that make sense? Yeah.
Is there a limit for all these planets?
Is there a limit to the universe? Okay. At least the way we think of it is that the universe is limited to 13.7 billion light years. Okay? So the question becomes, where does it go from here? And there are two possibilities. Well, three possibilities. That it would either, keep growing at a faster and faster rate, or it will keep growing at a steady rate, meaning it will slow down, but keep growing, or eventually will come back together. And we don't know the answer to that yet. Yes, I will come back to you. Yes, go ahead.
What are scientists' interpretation of why this Earth has an atmosphere we can breathe in, but like Mars and Mercury, their atmosphere we can't breathe in?
So Mars, for example, it was believed that at some point, actually Mars has a thin atmosphere. Okay? Not we. I mean, there isn't enough for us to breathe. But it was believed that at some point, Mars had a thicker atmosphere. which is why scientists are interested to know whether life was there on Mars at some point in the past. So they think that it's possible that Mars had life in the past. Lena. Yeah, it will explode basically, yeah. All the elements will be. Well, okay, I doubt that the Bible was talking about that point of cycle in the sun, because we're talking about something which is 4 billion years in the future, right? I mean, it's very possible that the Bible is referring to something which is much more likely to happen. For example, if the sun heats for whatever reason, which can happen, because sun goes through cycle, that it will become so hot now here on Earth. In fact, we see global warming happening, so it's very possible the Bible is talking about global warming. Yeah.
Now, the formation and the evolution of the stars and galaxies around our galaxy, do they affect, in other words, I noticed you mentioned that when it explodes, then it becomes gases.
Mm-hmm.
Now, so the elements really are always there. If they are not there, does that affect our universe?
By our universe, you mean our planet? Or?
Planet.
I mean, again, the way that suns are thought of is that they are generations. For example, first generation sun is the first sun that forms from hydrogen gases. That creates heavier elements and expands, explodes, and so on. Because it creates heavier elements, those elements come together again and they form a second generation sun, right? And it creates yet heavier elements. So it's like multiple generations of suns, basically, that creates heavier and heavier elements. So life for us, as we know it, is essential to have this cycle coming from all the different stars around us, which created the material necessary to create our solar system.
So we can conclude, in a sense, that God has created all of that in that form for our benefit, or for the benefit of.
For benefit
this
of
planet.
well, it's for the benefit of bringing life to, bringing man to creation.
Formation. It starts from helium and then the hydrogen. So, but where was the helium before?
So helium is formed from hydrogen.
I know.
Hydrogen is the first thing that was formed, and it was formed in the first 3 minutes of creation. Hydrogen is the most basic element you can find in nature. It's formed of proton and electron. Proton and electrons are the basic elements that build everything else, basically. So 2 protons and 2 electrons form heliums, and so on. So you go up one at a time. But all the hydrogen we see around us today is formed in the first 3 minutes of creation. Once those are formed, there is no more hydrogen in the making anymore. Hydrogen is not made anymore. You understand? It's the building block. Everything else is made from that. Lina?
They consider us as being elements. That means the elements as definition in research, or elements as being like material elements.
As being like, let's say in our body there is calcium, there is carbon, oxygen, iron, and all these things are formed one way or another inside of a star. Okay?
Scientists claim that Earth is supposed to be 4.5 billion years old, not 14 billion years old. So how would you explain the gap between
14 billion is the age of the universe. So the Earth formed about 4.5 billion years ago. Okay, we'll come back to that. Okay.
Dissolve, will it still make light or no? Like, will it still make light for us to see, or will it just?
It will go. It will explode. It will. That's right. There are many ways in which the different suns can transform. Some become what's called white dwarf. Some become neutral stars. Some become black holes. It all depends on the mass of the sun. But our sun is a small one, which will only. Sorry? Well, let's consider there is 100 billion galaxies. Each galaxy, on average, has 100 billion suns. So multiply 100 billion by 100 billion. You get 10,000 billion billion, okay? Yeah.
And the sun does the same for its own, like our sun for our planet, Yani? Is it the same function?
Pretty much. I mean, suns vary quite a bit in their sizes. Some are very short-lived, some are long-lived.
Can we borrow a sun from another planet?
No. Let me take those questions. You have questions there? Yeah, go ahead. Yeah.
How many suns are out there? I mean, right now, from the Earth, we only see one sun. But you're saying there's billions
Every star is a sun. Every star you see is a sun.
There's only one sun in the galaxy.
No. I'm saying in our galaxy, there's about 400 billion suns. Our galaxy. Every star is like a sun. I'm counting every star as a sun. Every star is a sun, correct. That's how it is.
But they're not radiating heat.
They are. But we don't feel it because they're too far. So their effect on us, as far as heat is concerned, they are very far, yeah.
So basically now, if we come back and we talk about this 6 days that God created the world in it, and you said there's no way that in one day He creates this whole universe. There's no way.
In 6
no
days, yeah.
matter what, if we read in science, whether it's the universe or it's the Earth, cannot be created in one day or 2 days or
No,
6
okay,
days.
let me put it this way. God can do anything, okay?
Amen for that.
He can create everything in 1 day, in 1 second. All I'm saying is that evidence doesn't support 6-day creation in the literal sense, okay? Now, you might hear very prominent theologian who will teach you that 6 days means 6 days, and that's okay. If that's what they want to teach, that's okay. But in my opinion, people who insist on 6-day creation in the most literal sense are similar to people who opposed Copernicus and Galileo in thinking that the Earth is not the center of the universe. Okay? They are taking the same attitude in terms of how to read the Bible. And they are thinking that if we believe in an old universe, that we are undermining the legitimacy, I'm too dry, I guess, of the Bible, but we're not.
For the clarity, you said Mars. The scientists believe that there wasn't that thick enough atmosphere to support life.
Yeah.
So we're talking about life. We're not talking about human life or extraterrestrial life.
Correct.
We're talking about like microorganisms.
That's correct.
To a cellular. We're not talking about a human level.
Correct.
Or yeah.
You see, scientists discovered that all you need for life is water. You don't need an atmosphere. See, even on our planet, they don't live in an atmosphere. Like people, I mean, creature living in the sea, they don't need an atmosphere.
I think that's where it gets, because when you say life.
No, life just means like.
We think humans.
Got you. Yeah.
We don't go down to the smallest level.
Yeah. Microbiology. Okay, I'm gonna give a chance to others. Yes.
Is God interfere in every age, as you said, of creation, or just He created the first step and it developed by itself?
Okay, there.
Maybe a big question.
Okay.
It's very important.
The Christian doctrine, the Christian teaching is that God not only created the universe and let it run, but He's actually maintaining the universe. Okay? Because it says that the universe is standing by His words. And actually, the biggest mystery for science today is what holds the galaxies together. Because what they discovered is that if they account for all the matter that they see, they can only see 5% of the matter that's needed to cause galaxies to rotate around and to cause them to hold their position. Exactly, that's what scientists are grappling with. So they come up with two things that are needed to actually keep the universe the way it is. They call one of them dark matter. Dark matter, they said it accounts for about 25% of what's needed, and the rest, about 70%, comes from what's called dark energy. Now, these might seem a little bit science fiction, but they're actually part of mathematical formations that comes out of equations and so on. But I'm saying that these are the biggest mysteries that science are now grappling with. What's holding the universe together? Of course, but there are two theories. The Christian theory is that God is maintaining the universe. The other belief, which says that God basically created the universe based on a set of law and let it go. There are people who believe that, but that's not the Christian position. It's not the Christian position, yeah. All right, now you can ask, I guess. Michael, tell us when we have to finish.
We have a room time for 2 more questions, and that's it. Mine is simple. Those 3 minutes are light minutes?
No, these are actual minutes.
Actual hour minutes?
Hour minutes.
What 3 minutes? Original 3 minutes. From creation until from the Big Bang?
From the time of the Big Bang until all the matters that we see form, all the hydrogen forms, you say. There's 3 regular minutes. Well, yeah.
God started everything in 3 minutes. All the creation. It doesn't take 600 billion years. He must have created.
Yes. Go ahead. I can't hear you. Good question. It's actually a larger, it's a larger than average galaxy. Is the Milky Way bigger or smaller than other galaxies? It's a bigger than a medium average galaxy.
Can these astronauts which go up from time and again, can they do something or attract or push them or anything like that? Human beings to interfere with all these galaxies?
No. It's like saying, can you push this building and make it fall? I mean.
Okay. We have one question, and
Yes.
the last question right here.
Okay.
That's a lot of pressure.
Sorry.
You showed us the other planets revolving. How come you left out Pluto and Mercury and the other ones?
Well, I showed you a picture which include Mercury and Pluto. The image that did not include those because those planets were not discovered until like in the last 100 years or so.
Last question.
So, because every time I was brought up, everyone's my parents. So I was brought up that Big Bang is, you hear Big Bang, automatically no. So what I've concluded from what you're saying is basically God has gave it a push. He was the push. The Big Bang.
It was the cause.
The cause of it. He was the
cause of
initial
it, yeah.
reaction.
Yeah.
And then as time went on, it expanded bigger and bigger.
Right.
Based off of the code.
He maintained it bigger.
No, no, that's not what I'm saying. So as it gets bigger, he's maintaining it, but that's not what I said. So he gave it the initial, like you're starting, for me, I put everything to food. So I'm pushing the start button on the microwave for the popcorn. Okay, I put 1 minute and 30 seconds, and I sit there because I don't like burnt popcorn. So I sit there and I watch it as it's popping, and as I hear it start slowing down in the middle of the pops, I stop it because I'm in control. So that's what God does. He's maintaining it there, but
Yeah.
he initially pushed it. So we can be believers in Christ and still believe
Absolutely.
in the Big Bang Theory.
There are many Christians who very strongly believe in the Big Bang. And let me tell you that the Catholic Church officially accepts the Big Bang as, yeah, I will. It's accepted as its doctrine, basically. The Big Bang is the moment in which everything came to existence. All, space, time, and matter all came to existence.
There was
nothing, and then something happened.
So is there any other name for it, or they used to call it another name and then they came up
Yes,
with the name?
yes. And God said, let there be. And that was. Okay.
شو بيسموه بالعربي؟
I have no idea.